Hello world! Welcome to another enlightening episode where we delve into the fascinating world of technology. Today, we discuss a topic that's integral to our digital lives: data storage. In our increasingly digital society, data has become the lifeblood of modern life. Every second, billions of digital transactions take place around the world, from social media updates and online purchases to remote work and virtual learning. All these transactions generate data, and that data needs to be stored somewhere. That's where data storage devices come into play. These devices, which come in many different forms, are designed to store our digital data. They're like the digital equivalent of a filing cabinet, keeping our data organized and accessible when we need it. Now, you might be wondering why we need to innovate in data storage. Isn't it enough to just have somewhere to store our data? Well, not quite. As our digital activities become more complex and data-intensive, our storage needs also evolve. We need storage devices that can not only store large amounts of data, but also access that data quickly and reliably. This need for innovation has led to the evolution of data storage devices. In the early days, we had magnetic tapes and floppy disks. Then came the hard disk drives, which revolutionized data storage with their high capacity and relatively low cost. But even these have their limitations. Today, we're witnessing another shift in data storage technology, from traditional hard disk drives to more modern and efficient technologies. These new technologies offer a host of advantages, from faster data access and higher reliability to smaller physical size and lower power consumption. This brings us to the focus of our discussion today: the solid-state drive, or SSD. But before we delve into the world of SSDs, it's important to understand the technology that they're replacing: the hard disk drive, or HDD. Now that you know why data storage is so crucial, let's delve into the first type of storage device we have on our list: the hard disk drive. Having understood the importance of data storage, let's take a step back and walk through the evolution of data storage devices, a journey that has led us to the doorstep of solid-state drives. Our journey begins in the mid-20th century with the invention of magnetic tapes. These tapes, similar to those used in audio cassettes, were the first widely used data storage devices. They were cheap, reliable, and could store a surprising amount of data for their time. However, they had one major drawback: they were slow, very slow. Accessing data on a magnetic tape was like trying to find a specific song on a cassette tape. You had to wind forward or backward until you found the right spot. In the 1970s, a new technology emerged that would change the face of data storage: the floppy disk. These were a quantum leap forward in terms of accessibility and speed, but they could only store a limited amount of data, a few hundred kilobytes at most. Then came the game changer, the hard disk drive, or HDD. Introduced in the 1950s, but only becoming mainstream in the 1980s, HDDs revolutionized data storage. They offered capacities measured in gigabytes, then terabytes, and data could be accessed in any order, almost instantly. For decades, HDDs have been the go-to solution for data storage. They have powered our computers, our servers, and our digital lives. But as we've seen, they're not without their drawbacks. As we move into an era of ever-increasing data demand, with applications like 4K video, real-time analytics, and machine learning requiring rapid access to large amounts of data, HDDs are starting to show their age. The need for faster, more reliable, and more efficient data storage is more pressing than ever. This is where solid-state drives, or SSDs, come into the picture. But before we delve into that, let's understand the technology that SSDs are set to replace: the hard disk drive, or HDD. Hard disk drives, or HDDs, have been the backbone of data storage for decades. But what exactly are they? Well, let's delve into the world of spinning platters and hovering heads to unravel the mystery of HDDs. At the heart of every hard disk drive are circular plates known as platters, coated with a magnetic material. These platters spin at high speeds, often several thousand revolutions per minute. Suspended just above these spinning platters are the read-write heads. These heads move back and forth across the platter surface, reading data by detecting the magnetic fields and writing data by changing these fields. This design, while effective, is also the source of many of HDD's limitations. One of the most noticeable limitations of HDDs is their performance. The speed at which data can be read or written is intrinsically linked to the speed of the spinning platters and the movement of the read-write heads. Compared to modern data processing speeds, this mechanical operation can feel like a snail's pace. Another significant limitation is the risk of mechanical failure. The moving parts within an HDD are delicate and can be damaged by physical shocks or wear over time. This makes them less reliable and less durable than some more recent data storage technologies. The physical size of HDDs is also a point of contention. To accommodate the spinning platters and moving heads, HDDs need to be relatively large. This can make them a less appealing choice for compact devices like laptops or mobile devices. Finally, HDDs are notorious for their high power consumption. The energy required to keep those platters spinning and heads moving can add up, making HDDs a less energy-efficient option. While HDDs have served us well, technology never stops evolving. Enter the solid-state drive. Solid-state drives, or SSDs, are the new kids on the block in the world of data storage. But what sets them apart from HDDs? Well, let's dive into the mechanics of it all. SSDs, unlike their HDD counterparts, don't rely on moving parts to read and write data. Instead, they use flash memory chips, which are essentially electronic circuits, to store information. This means that when you save a file to an SSD, you're not waiting for a read-write head to find the right spot on a spinning magnetic platter. You're writing directly to an electronic chip, which is significantly faster and more efficient. This lack of moving parts also gives SSDs a considerable edge over HDDs in terms of reliability and durability. Because there's nothing to wear out or break, SSDs are less prone to mechanical failure. They're also less sensitive to physical shocks, which can be a real plus if you're prone to knocking your laptop off the coffee table. But the advantages of SSDs don't stop at speed and reliability. They're also smaller than HDDs, which means they take up less space in your device. This has opened up a world of possibilities for device design, allowing for slimmer, lighter machines that still pack a serious storage punch. And let's not forget about power consumption. SSDs require less energy to operate than HDDs, which not only helps to extend the battery life of your devices, but also makes them a more environmentally friendly choice. Now, SSD technology has evolved quite a bit since its inception. Milestones like the development of NAND flash memory, the introduction of the SATA interface, the shift to the PCIe interface, and the advent of 3D NAND technology have all played a part in making SSDs the powerful, efficient storage solutions they are today. As you can see, SSDs offer a myriad of advantages over traditional HDDs. But what does this mean for you as a user? The advantages of SSDs are not just limited to speed and efficiency. There's a lot more to these powerful storage devices. Firstly, the speed of SSDs truly sets them apart. They boast faster read and write speeds, which directly translates to quicker boot times and faster application loading. This is because SSDs use flash memory to store data, allowing for instant access, unlike traditional hard drives that need to physically locate data on a spinning disk. This speed is not just a luxury, it's a necessity in our fast-paced digital world. Now let's talk about latency. Lower latency is another key advantage of SSDs. With an SSD, data can be fetched almost instantly, rendering long loading times a thing of the past. This feature is particularly beneficial for tasks that require intense data access, such as video editing or gaming. Next, we have reliability and durability. SSDs are incredibly robust because they have no moving parts. This makes them less prone to mechanical failure, which in turn increases their lifespan. They can also withstand physical shock, temperature changes, and even magnetic fields, which could spell disaster for traditional hard drives. In terms of size, SSDs are significantly more compact than their HDD counterparts. They come in various form factors, such as M2, PCIe, and SATA, offering greater flexibility for installation. This means they can fit into a wider range of devices, from ultra-thin laptops to high-performance desktops and servers. Lastly, SSDs are much more energy efficient than traditional hard drives. They consume less power, which not only saves energy, but also extends the battery life of mobile devices. This makes them an ideal choice for energy-conscious users and green data centers. With all these advantages, it's no surprise that SSDs are quickly becoming the preferred choice for data storage worldwide. So, we've explored the world of HDDs and SSDs, and it's clear that SSDs offer significant advantages. From the dawn of data storage, we have seen a tremendous evolution. Traditional hard disk drives, with their magnetic platters and red write heads, have served us well, but they have their limitations. They're slower, prone to mechanical failure, physically larger, and consume more power. Enter the solid-state drive. It's a game changer. With no moving parts, SSDs use flash memory chips to store data. This results in faster performance, lower latency, and increased reliability. They're smaller in size, providing more flexibility for installation, and consume less power, making them the perfect fit for mobile devices and energy-efficient data centers. We've also journeyed through the key milestones in SSD technology, from the development of NAND flash memory to the introduction of interfaces like SATA and PCIe, and the groundbreaking 3D and NAND technology. Each of these innovations has played a crucial role in enhancing the performance and efficiency of SSDs. The benefits of SSDs are not just theoretical, they translate into real-world advantages. Faster read-write speeds and lower latency mean quicker boot times and application loading. The absence of moving parts improves reliability and durability. The compact size and diverse form factors of SSDs, including M2, PCIe, and SATA, offer flexibility in installation. And let's not forget the reduced power consumption, which is a boon for our increasingly mobile and energy-conscious world. In a nutshell, SSDs have revolutionized data storage, offering a potent combination of speed, reliability, flexibility, and energy efficiency. They have set a new standard, one that traditional hard disk drives simply cannot match. The future of data storage is here, and it's solid-state drives. Thank you for joining us on this journey into the world of technology. Until next time, keep exploring,